Alright, so we want to find the limit as x approaches 8 from the positive side, or 8 from the right side, of this function. We got 1 over x minus 8 minus 1 over ln of x minus 7. Alright, so let's just go ahead, let's just plug in the 8 first and see what we get. Okay, so we end up with 1 over, now when we approach 8 from the right side, right, 8 minus 8 is a very small number, right, pretty close to 0. And then when we plug in the 8 here, we get ln of 1, which is also about 0. Okay, now this is an indeterminate form, right? This is infinity minus infinity. Okay, remember it's not really 0, right? I'm just writing 0 here. Okay, but it's a really, really small number. Okay, so 1 divided by a really, really small number is going to be infinity. Okay, so we get infinity minus infinity. So that tells us that we can do something with this guy, right? We can do a little bit of algebra. Okay, so what I'm going to do here is I'm just going to combine this all into one fraction. Okay, so that's generally what we should try to do, right? Because remember, we want to get a fraction divided by a fraction, and that's the indeterminate form that we want, right? 0 over 0 or infinity over infinity. In this case, the LCD is going to be the x minus 8 and the ln of x minus 7, which means then that this fraction, right, the first fraction needs that ln of x minus 7, and then the second fraction needs the x minus 8 in the denominator, right? So we get that x minus 8 here. Okay, so it looks a little bit complicated. Okay, but let's plug in the 8 again, right? So when we plug in the 8, what do we get? We get ln of 1, okay, minus 8 minus 8, all divided by 8 minus 8, and then ln of 1 about, right? So what do we get? We get 0 minus 0, and then 0, 0, right? So here we get everything's going to equal 0 here, right? So we get 0 over 0, which is an indeterminate form. Alright, so that means we can use L'Hopital's rule, right? We should be able to take the derivative of the denominator, whatever that is, and then we'll take the derivative of the denominator. Okay, so let's try that. The limit as x approaches 8 from the right side. Okay. Now this was pretty straightforward. The derivative of ln of x minus 7 is just 1 over x minus 7. And what's the derivative of this x minus 8 term, right? That's just going to give us a minus 1. Okay. And we'll take the derivative of the denominator. Now in this case, we have a product, right? We have x minus 8 times ln of x minus 7. So we're going to have to use a product rule on this guy. Okay, so if we call this the first function and call that the second function, okay, so we get 1 times the ln of x minus 7 plus 1 over x minus 7 times x minus 8. Okay, so I just use a product rule on this guy, and this is what we end up with. Once again, pretty messy, right? But let's plug in the 8 again. Okay, so when we plug in the 8, what do we get in this case, right? We get 1 over 8 minus 7, okay, which is 1. So we get 1 minus 1 all over. We get ln of 1 plus 0 over 1. Okay, so what do we end up with? Right, 1 over 1 is just 1, 1 over 1 is 0. Ln of 1 is 0, so we get 0 again. Okay, so we're going to have to use L'Hopital's rule again. Okay, but notice at this point, this looks pretty messy, right? Okay, looks pretty messy. So I noticed that I have an x minus 7 here and an x minus 7 here. So what I'm going to do is I'm going to multiply everything, right? I'm going to multiply the numerator by x minus 7, and I'm going to multiply the denominator by x minus 7. Okay, I'm going to write on this side here. Okay. So what happens when we do that? Okay, so once we multiply everything by x minus 7, you notice in this term, the x minus 7 cancels out. So we get still the limit as x approaches 8. Okay, we get the 1 minus x minus 7 on the numerator. Okay, Now what happens on denominator? Okay, so here we get x minus 7 times ln of x minus 7 times x minus 7. I guess I should write that x minus 7 in the front. Okay, and then notice what happens here, right? If we multiply this times x minus 7, that x minus 7 here on the bottom cancels out. That just leaves us with x minus 8. Okay. Okay. So now we should plug in the 8 again. Okay. For some reason, this minus sign is not going to turn out here. Okay. So keep that in mind here. Let's plug in the 8 again. Okay. So we get 1 minus 1, we get 1, ln of 1 down here, we get 0 down here. Okay, so everything cancels out. Remember, we just rewrote this guy, okay? So we just rewrote this guy, so we know that we're going to get 0 over 0. So let's do L'Hopital's rule just one more time, okay? Hopefully just one more time to do the trick, okay? So let's write that again, okay? So what do we end up with? We ended up with 1 minus x minus 7. Okay, we ended up with the x minus 8 plus x minus 7 times ln of x minus 7. Okay, I just rewrote again. I think I switched the order around here. Okay, but this is what we ended up with. Now still the limit as x approaches 8 from the right side. Okay, once again, we know when we plug in the 8 in here, right, we're going to get 0 over 0. Okay, so we do need to take the derivative of this guy one more time, right? So take the derivative of the numerator, and then take the derivative of the denominator. Okay, so what's the result? Okay, so the result is going to be still the limit as x approaches 8. Okay, well, so what do we get in the numerator? You notice we get a 1, which is the derivative of 1 is 0. The derivative of negative x is negative 1. Okay, so that's all that's remaining on the numerator. Now on the denominator, what do we get? Okay, derivative of x is just 1. The derivative of 8 is a constant, so that's just 0. Now we have to take the derivative of this guy, which is a product, okay, which means we're going to have to use the product rule again. Okay, so we're going to take the derivative of each piece here, okay, and use the product rule on this guy. So the derivative of x minus 7 is just 1. So 1 times ln of x minus 7 plus. Now notice what happens here, right? The derivative of ln of x minus 7 is 1 over x minus 7 times x minus 7. And notice that turns out pretty good here, right? This actually cancels out to equal 1. Okay. So what happens when we plug the 8 back into this whole thing here? Okay. We end up with negative 1 over 1 plus ln of 1 plus this one right here. Okay, so that leaves us with negative 1 over 2, and that's going to be the limit.